Hey there, let me ask you a quick question. Have you ever tried pushing a heavy table and it just won't budge, but then suddenly it starts to move? But that was friction you were fighting with in that moment. Today we're going to break down friction, talk about what it is, its types, what it affects, and why it matters in real life. Come with me as we study this invisible but powerful force. So what is friction? Friction is a contact force that opposes motion. It occurs when two surfaces are in contact with each other and then one tries to slide over the other. You know, no matter how smooth a surface may seem, on a microscopic level, it's actually rough. There are ridges and bumps that create resistance when something tries to move across it. Friction is what allows us to walk without slipping. It's the reason why cars can grip the ground, and it's the reason why your pencil doesn't roll over your notebook every single time. Friction is in everything and it's everywhere. So let's talk about friction, shall we? We've got three types of frictional force. There's static friction, there's kinetic friction, and then we've got rolling friction. But let's start with static friction, shall we? Static friction is frictional force that acts on an object at rest. It's the force that prevents the object from moving. It adjusts up to a maximum value depending on the amount of force you're applying. So let's picture this. Imagine trying to push a couch, but then it just won't, no matter how hard you push it just won't move. That's static friction resisting you. But once you overcome it, boom, it starts sliding. Now let's talk about kinetic friction. Kinetic friction is otherwise known as sliding friction. Let's picture the couch in static friction. Once the couch starts to move, kinetic friction takes over. And kinetic friction usually is less than static friction, which is why it gets easier to push something that is already in motion. Let's try it. Try pushing a heavy box. At first, you'll feel the first push to be hard, but once it starts moving, it becomes easier to move it. Now let's talk about rolling friction. Rolling friction is resistance when something rolls over a surface, like a ball or a wheel. It's usually much less than kinetic friction. Which is why it's a lot easier to roll things. It's the reason why we have wheels and rollers to move heavy things. You can even test it out yourself. Try sliding a bottle across the floor and then try rolling it. You'll feel the difference. So now the big question is, what affects how much of friction that there is? Well, luckily, there are two main factors that affect the amount of frictional force. And the first one is the nature of the surfaces. Now, rougher surfaces cause more friction because on a microscopic level, they have more ridges and bumps that offer more resistance, which in turn leads to more frictional force. But then smoother surfaces, on the other hand, have less ridges and bumps, which turns to less resistance, which in turns to less friction. You can try it yourself. Try sliding a book over a piece of glass, and then try sliding the same book over a piece of sandpaper. You will feel the difference. Now the next factor is the normal force. The normal force is the force that is pressing the two surfaces together. For flat surfaces, it's basically the weight of the object. So heavier objects have more normal force, and more normal force you have means more friction. So you can try it out yourself. A piece of box containing maybe shoes would have less normal force than a bag of rice. Surprisingly, friction doesn't depend on surface area. A wider object doesn't necessarily cause more friction, as long as the weight and the surface texture remains the same. So now, I'm going to show you a bit of math that will help us to know how to calculate frictional force. The formula is F equals to mu N. Here, F is the force of friction and mu is the coefficient of friction. The coefficient of friction is a number that depends on how rough or smooth a surface is. Then N is the normal force. The normal force for flat horizontal surfaces is usually just the weight. So N is equals to mg. So let's take a look at this question. It says a box of mass 10 kg is resting on the floor. The coefficient of kinetic friction between the box and the floor is 0.4. What is the force of friction? Now to calculate this, we first find the normal force. Come with me. Normal force is given by mg because the box is resting on a flat surface, which is the floor. Now we have found the normal force. The next thing to go on to find is the force of friction. So now we've been given that the coefficient of friction, which is mu, is 0.4. So then to find the frictional force, we just multiply the coefficient of friction by the normal force. Easy peasy. The frictional force is 39.2 newtons. This tells us exactly how much force you need to apply to keep the box moving at constant speed. So now let's take a step back and ask ourselves, is friction actually useful? I mean, do we need it? Is it bad? Is it good? Of course, friction is useful. It lets us walk without slipping. Cars can move and stop because of friction with the road. And friction between our pens and papers lets us to write. But friction can sometimes be a nuisance. It causes wear and tear in machines. It generates unwanted heat. It reduces efficiency in moving parts. So that's why we use lubricants like oil and grease to reduce friction and help machines last longer. So now, let's recap everything we learned today. We said friction is a force that opposes motion between two surfaces in contact. We established that there are three main types of frictional force: static friction, kinetic friction, and rolling friction. And then we said that friction depends on the nature of the surfaces and the normal force. We also learned a formula that can allow us to calculate the amount of frictional force. Formula being F equals to mu N. And then we established that friction is both useful and problematic in daily life. And that is friction. So next time, when you walk, write, drive, or even strike a match, remember, friction is quietly at work. Thanks for sticking around. If you've got any questions, please drop them in the comment section and I'll reply them as soon as possible. But until next time, stay curious and keep learning.